Triangle has two edges of length 5. What length should be chosen for the third side to maximize the area? Now we could make that third side pretty small, but that area looks quite small. Or we could make the third side quite big, but then I'm gonna get a small height, and that's also going to be quite small. So maybe there's a happy medium where we're going a bit like this. Try to make it so they all look about the same. I'm not done badly to get the maximum area. So that is going to be 5 and that is going to be 5. And then, all right, I've got some angle here and I want to know what this is. Well, the key really is to use the formula half equals AB sine C. And in this case, I'm going to call my angle x. So for us, it's going to be a half times 5 squared times sine x, because then the area depends completely on the angle that we set. So I want to make sine C as big as possible, and actually the most it can ever be is 1, and that is when x is 90 degrees. That ends up being the angle that will maximize it. Let me just talk about that briefly. It's different from our triangle, but look, we have just a situation over here with y. We've got the opposite over the hypotenuse. The hypotenuse is always the longest side, except you can imagine with this, we've got a right angle here. We can imagine just making y bigger and bigger. The most it could ever get would be kind of 90 when it sort of goes to here, and that's when the opposite will end up equaling the hypotenuse. It's a little bit confusing, but you sort of almost need to just accept that it's a definition of sine. You can't actually have two 90-degree angles in a triangle. But sine x can equal 1 when x is 90, which means the maximum area will be 25 over 2. But more importantly, we're asked to find the length of the third side, and for that we can use Pythagoras' theorem. 5 squared plus 5 squared square rooted, which gives us root 50, or 5 root 2. Actually, it always turns out when you have two sides the same in such a 90-degree triangle, if you have x and x, then the hypotenuse would be root 2x. And if you have the hypotenuse and you want to work back, you would divide by root 2. Like if I had, this often comes up in these math challenges. Like if I knew that was, for example, 7, and these two were the same, then I can just say straight away they must both be 7 over root 2. So I times by root 2 to go from here to here, and dividing the opposite, going the opposite way. Final answer then is C, 5 root 2.